today we're going to be talking about a little different kind of equation than we've been talking about. We've been solving equations in one variable. We've been solving for an x or a y or a z or whatever. Now we are going to start working on different forms of linear equations. All the equations we've been solving, if you graph them, there would be a vertical or a horizontal line, okay? Or you could even plot them on a number line. Now we're going to be solving linear equations and working with linear equations in two variables. So if you remember from last year, there are different forms of linear equations, but anytime you graph that equation, you get a line on the coordinate plane. Does that sound familiar, Martin? Okay. So the first thing we're going to talk about in regard to these linear equations is their slope. Does anybody remember what slope is? Rise or run is a form that we can, equation we can use to find the slope of a line. Xavier? I'm sorry, Ryan? No. You think you heard that from me? Danielle?
Y doesn't intercept.
That is slope-intercept form. Cole? Y divided, so change in y divided by the change in x is, so what I just want to know, what does it mean? If I have a line, what are the four types of slope you guys learned about last year? Do you remember? Negative is one. Positive is one. No solution. Not exactly. Undefined is one. There's one more. Zero. So there are four types of slopes. So, we're going to start with these notes, and let's draw this line. Doesn't matter where, you start at the top and go down on the other side, right? The slope of this line, what kind of slope does this line have? Very good. This has a negative slope. And how do we know that, Keishan? Do you remember? It's going down and, well, let's go real quick and do this one. So let's start at the bottom on the left and go up. So what kind of slope does that one have? That is positive slope. So I could see where you could say that they're both going up or they're both going down, right? But there's a criteria for that. The criteria is, the rule is, it's from left to right. So if they start down on the left and go up on the right, that's a positive slope. If they start up on the left and go down to the right, that's a negative slope. So we're going to put that in our notes. And I have it over here, I think. It's going to go down. Negative slope goes down from left to right. So down from left to right. So what do you think a positive slope does? It goes up from left to right. That's right. So slope refers to how, well, let's just finish our four types since you guys knew that. All right, so now we've got another type. All right, so Keishan said zero. You guys said there's a zero slope and an undefined slope. Is this a zero slope or an undefined slope? This one, so let's look at the difference. So these are the other two, what they look like. This one is undefined. This one is zero. So that's what we're going to write. You don't actually have to have any work for undefined or zero slope lines, so I'm going to show you an example, and then after that, you won't have to have many more. But what I do need you to know, let's see if I can get it out here. So that one is a vertical line, right? Vertical, we need to start getting used to these terms because we're going to use them a lot. And this flat one is a horizontal line. So a zero slope, think about, if you think about slope as in steep slopes, a really steep slope, have bunny slopes. I don't know if any of you guys have ever been skiing, but they're very flat and not dangerous. This one, no one can see that. That's just like falling off a cliff, right? It's too steep. All right, so the steepness, so the slope is the steepness of the line, or of a line. And the greater the absolute value, the steeper the line. So, if we're comparing, well, let's see a second. What do you guys say? You have a formula, and one of you guys mentioned this formula. Good job. Y minus y over x minus x. M stands for slope. And remember, the y and the x are x coordinates. Right? So this is a y coordinate minus a y coordinate. Oh, so Keyshawn is really remembering his lesson from last year. Keyshawn said, don't you have to put y sub 1 and y sub 2? You don't have to. All right, you can though, if you're more comfortable doing that, Keyshawn. So a lot of times you'll see this formula with subscripts. It'll be y sub 2, the 2 here, minus y sub 1 with the 1 there. But really, all we have to remember, Keyshawn, is this is an order pair. So if you use the y from an order pair here, you have to use its x there. The order doesn't really matter. First or second doesn't matter. We just have to line them up. Does that make sense, buddy? Okay. So the slope is a numerical value. So that we can say it's positive or negative, but there's a numerical value for the slope. The slope has a numerical value. For some reason, that board is not letting me. Slope is, let's say, is a numerical value. So that's why we said here, the greater the absolute value, the steeper the slope. So if we have a line with a slope of negative 4, and if we have a line with a slope of 1/2, which one is the steeper line? Well, negative 4 is a smaller number. Remember, absolute value says how far is it from 0. So the absolute value of 4 is 4. Absolute value of 1/2 is 1/2. So we're going to say the slope of line 1, the slope of line 2. So line 1 would be steeper because it has a greater absolute value. Hayden? Right now, maybe. Not in the morning. If we have time at the end, I will assume, but I don't think we're going to have time to go full past 30 minutes. If it becomes an emergency, let me know. Are y'all kind of with me? All right, so the other thing you guys talk, okay, let's talk about this. So when we say that this is a numerical value, if this slope, whatever it is going to have a negative sign in front of the number. This slope, whatever sign it is going to have a positive. It will be a positive number. It can't be a negative number. This one will always, m will always be equal to 0. This one will always be undefined. There will be no numerical values for those two. Does that make sense? Well, I lied. There's a numerical value for 0 because 0 is a number. But there's no numerical value for undefined. That's the only one there's not. All right, so let's look at the bottom of this page before we go. Rise over run, someone mentioned that, and that is a formula that we can use to find the slope if they've given us a graph. At the bottom of this, it says we use rise over run to find the slope when given a graph. And this is the formula. Rise over run is actually the formula. We say rise over run, but really it's the rise divided by the run. And if you recall from last year, rise refers to up and down on the coordinate plane. Run refers to left and right on the coordinate plane. If we're looking at this line, at a glance we can tell if does this line have a positive slope, a negative slope, an undefined slope, or a zero slope. What do you think, Diane? Positive. It goes up from left to right. Now, if we're finding the slope, just saying positive is not enough. Lee, will you take your headphones off? Everybody can still have your headphones or on or anything, take them out. Alright, so this one does have a positive slope, and now we actually want the numerical value for this slope. So what we're going to do is we're going to look to see, okay, how far do we have to go up and over to get from one point to another point? So lines are made up of an infinite number of points. What does it mean for something to have an infinite number of something? You can't count them. It just goes on forever, right? So when we look at these lines in a coordinate plane, they're really made up of so many points that they're connected. They look connected, right? There's so many points. These lines are made up of so many points that they look like a solid line. So many points that they look like a solid line. We can take any 2 points we want. We count from one point to another point, and that's one way that we can find the slope of the line. So down here, we're going to put below that we're going to be counting from one point to another. That's how we use the rise over run formula. We're going to count from any 2 points in that line. Now, we get to pick those 2 lines. Sometimes they'll be marked for us. If they're marked for us, they're marking them for us so we can count the actual boxes. So when you pick 2 points, you want to take points on the line that cross right at the little vertices, right where the lines meet. That way we know exactly how many blocks or boxes we're counting. Another thing real quick, do we know, if you go up on a coordinate plane, is that positive or negative? Good. If you go down, is that positive or negative? If you go to the right, is that positive or negative? Good. And if you go left, is that positive or negative? Okay, so that's something we need to know, because remember, it's numerical, so we need to know, are we dealing with a positive or a negative number? It's going to be a fraction. Now, I'm going to make this bigger. So I can see it better. All right, so I'm going to start with this point, because it crosses at a nice, neat vertices. And I could use this point, or any point that crosses nice and neatly, but I think this is the point I used first period, so I'm going to use that one. Any 2 points, we will get this. Any 2 points you pick, you will always get the same slope if you do it correctly. Alright, so I can count from this point up and over to that top point, or I could start with the top point and go down and to the left, right? Either way, it doesn't matter. I'm going to start with the bottom one this time. So if I start with the bottom one now, my rise number tells me how far I go up or down. And I'm going to go up or down just to get even with the point. So we're going to count. So if you want to put on your notes, I put it at 1, 2, 3, 4 down on the y-axis. And I went from this middle point, we call that the origin. I went 1, 2, 3 to the right, and 1, 2, 3, 4 up. So put your dots in the same place I put mine. Alright, so the rise, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. If I'm going up, that's a positive 8, right? And now, from there, am I going to go left or right to get to my line? Right. Is right positive or negative? Okay, so that's going to be a positive number, a positive 1, 2, 3. So my run is 3. So to find my slope, I plug in rise over run, right? Because that's the bottom. So our slope is rise over run. So that number is so this slope, the slope of this line is 8/3. Okay? So let's look at this line. What kind of slope does this line have? Zero. I want to prove to you that it has a zero slope, and after this, you don't have to show me work for horizontal. If you're asked to find me or give me the slope for a horizontal line, you can just tell me it's a zero slope. If you're asked for an undefined line, you can just tell me it's undefined. But for today, I'm going to show you the work. We're going to take, I'm going to go 2 to the left, and 1, 2, 3 to the, we'll go 2 to the, 1, 2, 3 to the right. Right, so we got these 2 points, right? So how far am I going to go up or down to get to the other point on the line? 0. So my rise is 0. Now I'm going to go left or right to get to my other point on the line? Right. So I'm going to go 1, 2, 3, 4, 5, right? That's a positive, right? So then my slope is 0 divided by 5. But now we have to simplify. You always have to simplify that fraction. Slope always has to be a fraction or a mixed number or a whole number, not a mixed number, my bad. An improper fraction, a regular fraction, but not a decimal, not a mixed number. Does that make sense? Okay. It can be a whole number. All right, what is 0 divided by 5? Everybody should have their calculator. On your calculator, be 0 divided by 5. 0. 0 divided by any number is 0. So the slope of this line is 0. And a reminder, this is a horizontal line. I want to write it a couple times because I need that to stick in your memory. So 0 slope is a horizontal line. So, got it with me? Now we have this line. Do we know what the slope of this line is? It's undefined. We're going to prove it's undefined. So let's do that. So let's pick 2 points. I'm going to pick a line, the point right on the x-axis and y-axis, and I'm going to go up 1, 2, 3 points. So let's do that. So my rise, if I go, let's go down this time. Let's start at the top. So what is my rise if I start at the top point? 1, 2, 3, is it a positive or negative 3? Right, so if I go down here, that's a negative 3. Now, how far do I go left or right to get to my second point? 0. All right, so now let's plug it in. We have negative 3 divided by 0. I want everyone to do that on your calculator. Everybody do negative 3 divided by 0 on your calculator. What do you get? Everybody do it. Don't say it out loud yet. Everybody finish writing it and do it and see what you get. There's only one word that pops up on a calculator. Lee got error. Martin got an error. Did you do negative 3 divided by 0? Yeah, you got error, right? So you should get error. Error can't be your answer. You have to know that that is undefined, all right? So make yourself a note. Your calculator is going to say error because you can't divide by 0. You can divide 0 by any number, but you can't divide anything by 0, okay? So when you see error, error is not your answer. Error means it's going to be undefined. All right, let's go ahead and put a point right here on the y-axis for our last line, and then we're going to put a point right here. So that's 1, 2, 3 down right here. All right, so I'm going to start at this point, and I'm going to go down to meet my line. How far do I have to go down? 4? So if I start at the top, remember I could start here, but if I start at the top, I'm going to go down 4, which is negative 4, then I'm going to go right. 1, 2, 3, 4, 5, oh, yeah, 6. Right, 6, I was kind of moving on one, but right, 6. Positive, right is positive, right? Positive, negative, positive. So now we're going to plug it into our formula. The rise is negative 4 divided by positive 6. Do that on your calculator. 4 positive negative button, or divided by, actually do 4 positive negative button ABC 6, because we want it to be a fraction. Should be negative 2/3. Alright, and don't forget that this one over here is a vertical line again. I want you to write that. This one is a vertical line again. Alright, any questions? So let's look at our worksheet. Yes.
Look at,
Oh, yeah, let's do the back real quick. Okay, yeah, we'll do the back, the top of the back, and then we're gonna do these examples. You guys caught up with me? Alright, so find the slope of a line. When given 2 points on the line, you use the slope formula. And we've already put this on our first page. But remember, 2 points, they're going to be 2 ordered pairs. Remember, this is what an ordered pair looks like, right? An x coordinate and a y coordinate. So, an example here would be 2, -3. That's the x coordinate, and that's the y coordinate. Does that make sense? We've got to remember that the m always stands for slope. So now we're going to do a couple examples. We're going to do 2 examples. We're not going to do all of the examples on here. We're going to do 2 examples on your notes, and then we're going to do 1 of your homework problems so you have less homework. Okay? So let's look at your homework real quick. Problem 7, 8, 13, and 14, you're going to use rise over run for. So you might want to make yourself a little note. The strategy, if you're given a graph, you're going to use m equals rise over run for 13, 14, and 7, and 8. The definition of slope, we put in our notes. You can copy that later. The formula, number 20, we put that in our notes. You can do that later. Look at 9 through 12. All you have to do is sketch a line like we did in our notes. Sorry? What did you say? That's just the definition. You'll get that from your notes. So 19 and 20, you should be able to get directly from your notes. So we've already done examples like 7, 8, 13, and 14. 9 through 12 and 19 and 20 are both in your notes. Alright, so we're going to do that in a second. Don't get distracted. Now we're going to do some examples like 1 through 6. So we're only going to do examples 7 and 8, so you can just put your little line through those. Alright, we're going to do examples 7 through 8. Then we're going to do an example, we'll do 3 more examples, and then we'll do 1 homework problem. Okay, so if they ask you to find the slope of the line, they don't give you a graph, but they give you 2 ordered pairs. Remember, these are called ordered pairs. We're going to plug it into this formula. So we're going to always start with m equals, don't just give me y minus y. It's m equals. Now, you may want to go ahead at first and label x and x, y, and y, right? Remind yourself of which is the x and which is the y. I would make sure you put this formula in your worksheet for now, because our common mistake is the kids want to stick the x's on top and the y's on the bottom, and that will not give us the correct slope. So now we're going to do y minus y, so 4 minus -1, so that's y minus y, and now x minus x. Because I used the 4 first, I'm going to use the 6 first. I'm just going to do it in the same order. And now I don't have to worry about y sub 2 and y sub 1, x sub 2 and x sub 1. Support? It can, if you're more comfortable with that, yes. So this one is a little tricky to put in your calculator. So I would like for you to put the 4 minus -1 in your calculator first. 4 minus -1. When you do, you should get a positive 5. Right? Okay. Then let's put in 6 minus 3 in our calculator. You should get a 2. I'm pretty sure I subtracted 6 minus 3 wrong on the first reading. Oh, it's 3, no, okay. No, I just did that here. Okay, here we go. 3, there we go. I'm thinking, yeah, that's good. All right, so the numerical value for the slope of this line is 5/3. If you're not sure if that's simplified, you can put 5 ABC 3 in your calculator. If it changes, you use that. If it doesn't, I would actually like you to mix number and make second ABC again. And now you'll see that that actually is your simplified fraction. We don't want to mix number if it's an improper fraction, or mixed number, you want to give it an improper fraction. Alright, so who can tell me what to plug in for example 8? What's going to go on the top, Anson? Very good. Negative 3 minus 0. Y minus y. Now because Anson used negative 3 here first, we're going to use that for our x first. You'll see that this is this ordered pair, right? The ordered pairs just have to be lined up, stacked on top of each other. Does not matter which one you do first. And then the other x is 6. So just like in this one, let's do negative 3 minus 0 on our calculator, 0 minus 6 on our calculator. And now you can enter this using the fraction button and it will simplify it for you. So 3 positive negative buttons, ABC, 6 positive negative buttons, you should get 1/2. Okay? So the slope of this line is 1/2. Which one is steeper, 5/3 or 1/2? Greater absolute value. Since this is 1 2/5, that's more than 1, and this is the steeper line. Very good. All right, we're going to do this first example. We're not going to do this one. You can scratch that one out. And then we're going to do number 15 on your homework. So we're going to speed up a little bit. So we are going to use M equals y minus y over x minus x. But here's something different about this. If you look at this ordered pair, there's a variable in the ordered pair. So we don't know what that exponent is, and we're not looking for the slope. They're giving us the slope, so we're going to plug in and solve for the thing, solve for the variable. So what we're going to do is we're going to plug in for m, and when we do, we're going to move that negative sign up to negative 3/2. We're going to put negative 3 over 2. Does that make sense? And that's equal. So that's in this spot. Now, y minus y, y, and y. We're going to do 6 minus negative 3. And now this is an x, and this is an x. So that's going to be r minus 10. So we're going to bring this down, negative 3 over 2. We're going to do this on our calculator, 6 minus negative 3, and get 9. You don't have to do that on your calculator right now, because we're going to make sure we have enough time to do both examples. This can't be separated yet, so we're going to put that on the bottom in parentheses. So now, in this form, we've got a fraction equals a fraction. We're going to cross multiply. I got to go up here. If y'all have room to go down, y'all can just go down, but I got to go up here. So I'm going to do negative 3 times r minus 10 equals 2 times 9. Remember when you solve proportions, you cross multiply and then solve for the variable. So we plugged in. Now we cross multiply. Now we're going to distribute. Negative 3r plus 30, because it's negative 3 times negative 10 equals 18. Now we can read this out loud. It's negative 3 times r. We're undoing, multiplying by negative 3, and plus 30. So we're undoing, add 30. We're going to undo the adding first. And that's negative 3r equals divide by -3, and R equals positive 4. Any questions? All right, question number 15, so one less problem to do. Sorry? All right, well, you don't have to follow along. I was thinking one of your homework problems for you, but if you don't want to do that, you can do it on your own. Oh, okay, well, that's good then. So we do slope equals, so 3/4 equals y minus y, 11 minus -5, over x minus x, 7 minus r, with the parentheses around that. So we just plugged into our slope formula. So now this is 3/4 equals 16 over 7 minus r. And now this is where we cross multiply. So 3 times 7 minus r equals 4 times 16. So 21 minus 3r equals 64. Sorry? Remember that this is a positive, so we're undoing multiplying by -3, and we're undoing a positive adding 12, or 21. And then subtract 21 from both sides. -3r equals -43. Divide both sides by -3. And then r is +43/3. I'll tell you that you can't simplify that. But if you want to check it for your homework, you should put it in your calculator. 43 ABC 3 equals, it's going to give you a mixed number, the second ABC again, and you'll see that it's 43/3. Okay, so you really only have about 6 problems you actually have to do math for. All the other problems you can answer straight from your notes, okay guys? Yes, all the problems, doing all the problems.